glucose is C6H12O6. It is a monosaccharide. And anything ending with OSE is a sugar. Know that various different forms of C6H12O6. For example, what are the other examples that are similar to glucose with the same formula?
Fructose.
Fructose, and
Galactose.
lactose. And we're going to go ahead and take some of those as a disaccharide. So if we have glucose, that's going to be
Maltose.
maltose, glucose, lactose, lactose. Glucose, fructose is
Sucrose.
sucrose, table sugar. Okay, so memorize those in particular. Generally, carbohydrate, as in carbon, water, can have anywhere from a monosaccharide can be anywhere from 3 to 6 carbons in this case. The last one I want to look at is the pentose, because we're going to be needing to know this for. Let me just bring it up here. A pentose is going to be 5 carbons. And let's see if it's here anywhere. Oh, also the polysaccharides, you're going to have cellulose, glycogen in the liver. And what was the third one? Starch. Okay. Just know the names. I don't expect you to remember the structure. And there are other types of polysaccharides as well. Probably one I'm going to focus in on for the rest of the term is what's called a lipopolysaccharide. When you start taking a look at these names, start breaking them down. Lipo meaning fat, and then polysaccharide, a polymer of sugar. Unfortunately, most of your bacteria, some bacteria, have these lipopolysaccharides which slough off, especially when you have an infection. And these travel in your bloodstream all the way up to the hypothalamus in the brain and set off a fever response. So these are fever-inducing compounds. Of course, the body does not have an immunity to this. There's just so much of it out there. Or LPS for short. And we're going to hit that again and again and again all throughout the term. Peptidoglycan. This is going to refer to amino acids, protein, sugar, like glycan. So take a look at these names closely. Chitin, I don't expect you to really differentiate there. But here we can break the names apart. We're going to be doing that over and over again in this course. Okay, so glycogen you would have memorized for this case. All right, let's go back to carbohydrates again. If we have a 5-carbon sugar, so again, C5H10O5, we're going to have something called ribose. For 5-carbon sugars, and again, these are pentoses. Like a pentamer, 5 sugar. This is going to be important because we're going to be using these 5-carbon sugars to put together DNA and RNA as well. And the way we're going to do that, especially say an RNA, ribo from ribose, nucleic acid, ribonucleic acid, or RNA for short. And what's going to happen here is that we're going to be, as a backbone, we're not going to look at the bases right now, but the backbone of RNA will be alternating sugars and phosphate group. And that's going to repeat. So if you take a look at DNA, back of the DNA is going to be a 5-carbon sugar phosphate group, 5-carbon sugar phosphate. It's going to be the backbone on both of the spirals, which we take a look at later. For RNA, it's going to be the same thing, sugar and phosphate, except for the sugar, we'll be using ribose. For DNA, we're going to be using deoxyribose. So this is ribose here. Deoxyribose is going to be missing the oxygen. Still 5-carbon sugar, but here we have deoxy. You write that down over here. If it's deoxy, ribonucleic acid. This is where the word DNA comes from. So DNA is going to have a sugar it's being used that has 1 less oxygen. So you need to know the difference between what sugars are used in RNA and DNA. Again, both are alternating sugar, phosphate, all along the backbone. I think that was the last of the items on the carbohydrates. Let's see. Oh, the phosphate group. What is a phosphate group again? Let's just go ahead and use the book here. Again, this is part of the functional group as well. Just to review, I want you to know what amino is because that's going to be attached to your amino acid proteins. So amino, alcohol, OH group, carboxyl, C double bond O, OH, sulfhydryl, that's for another amino acid, cysteine, I want you to memorize. Another one will be, of course, phosphate is going to be considered a side group.
What was the last one?
Pardon?
What was the last one that you released?
I don't know. That was sulfhydryl. Probably sulfhydryl, SH. Sulfhydryl. That's going to be helping to create a bond. And we're going to go into this here secondly after break maybe. So phosphate group. For those of you remember the phosphate ion, if that is all that you memorize in terms of phosphate, that's great on that. But what's it look like? Double bond O. And even if you don't get all the pieces right on this right here, this is attached. And of course, it will also form part of the chain for RNA or DNA. But if this is just attached to the side group, it's still a functional group. All right. Actually, it looks like lipids are next. All right, so let's take a look at some of the chemistry here. You're going to need to know about the various groups of lipids. We're going to go ahead and write those down here as well. The biggest one here, of course, are going to be triglycerides. But let's see if we start off with a backbone here. So are high levels of triglycerides good in your blood? No. It can lead to plaque buildup. That's the reason why they're always wanting to bring that down. Triglycerides is also levels in your body are set up by stress. So the more stressed you are, the higher levels of these you're going to have. Let's see what they look like though. Okay, so we're going to start off with a glycerol molecule. These have 3 carbons and also 3 OH groups. So this is a trialcohol. So it has alcohol in groups in 3 places. It's also called glycerin. This is the stuff you're using in the chemistry lab on a little squeeze bottle to try to push that piece of glass tubing into the cork or your stopper without breaking and stabbing yourself. So it's very slippery material, but this is the basis for a lot of structure to your own cell membranes as well. So we're going to start here. We're going to go ahead and take a fatty acid, and by definition, a fatty acid is simply a carboxylic group carboxyl group attached to a hydrocarbon. So if I were to put up a picture like this and ask you to circle the functional groups, you'll circle the carboxylic acid side group here, label it, and the rest would be simply a hydrocarbon. So what's going to happen is that this will undergo a reaction. If I just do one of these, let's say I only attached one fatty acid to one alcohol. I ignore the rest of these here. If I do that, what you're going to see is I take a alcohol, basically, plus a fatty acid, and you're going to be making a simple wax. You already produce a lot of it yourself. Earwax, wax on beeswax, all sorts of other waxes out there are all based upon this chemical reaction. So you need to know that. Speaking about earwax, don't clean the earwax out of your canals. That is what's protecting you against infection. If you insist upon using a Q-tip, just do the edges and don't go down further. Otherwise, you're asking for swimmer's ear or other types of infections, especially from your normal flora, your staph and strep already on your skin. So try to avoid excess Q-tip usage. Otherwise, you're going to be addicted to Q-tips for the rest of your life. Okay, so important thing: alcohol, fatty acid, single alcohol, single fatty acid making wax. So what we're going to do now is take a look at triglycerides. We're going to do that 3 times. So what's going to happen is that you're going to wind up with 3 of these reacting to form what's called a triglyceride. This is what's floating around in your bloodstream. This is what's going to contribute to plaque formation as well. The bond you're going to have to memorize here is going to be called ester bond. Because what's going to happen is that it's going to react here. You have hydrogen and OH here. It's going to react to produce water. This is called a condensation reaction. Condensation. It's also called dehydration. Both these words are correct, meaning that you're producing water. So when you start to polymerize things, if you start to take your amino acids to make protein, if you start taking your nucleic acids to make DNA or RNA, if you start taking sugars to make cellulose or glycogen in your body, as it polymerizes, it's going to produce water. When you produce polymers, so in most of the cases here, if you have monomers going to polymers, you're producing water. This is called, again, either of these 2 terms that will be acceptable for that, condensation or dehydration. If you're going backwards, say you've taken a big chunk of meat and you're digesting the protein in your stomach, you're going to be adding water to this, to the polymer of your protein, adding back water to produce your amino acids. This is called hydrolysis. So the reverse reaction is hydrolysis. So going forward for polymerization, you're producing water. For hydrolysis, you're going to be consuming water and depolymerizing polymers to monomers. So know the words and terminology for both directions. Okay, and of course we just added now the ester bond too. Well, let's see. So it's O-C double bond O attached to another carbon here. This is a ester bond. Have you ever heard the word esterification? It's involved in soap making as well. We can talk about that a bit later.